Welcome back, I'm Sasha and this is part 2 of my UniSQ MTR1201 Millie's Flying Fish assignment. In this module, students are asked to complete the following. 1. Create a program that moves the tail to 5 discrete angles. 2. Show the servo and program are able to move the tail accurately by placing a protractor diagram beneath the fish and measuring the angles of the tail whilst the body is held still. And 3. Design a flowchart for the program used and provide a brief explanation. First off, a quick recap on the current state of my fish. As shown in part 1, we designed and assembled the physical body and wired up all the electronics as well. In the second test in that video, I programmed the servo to rotate between 0, 15 and negative 15 degrees from collinear with the body as shown again here. Since the first video, I've also enlarged the base to improve stability, and also slightly moved around several components as shown. Now that we're up to date with the state of my fish, we will move on to the program and flowchart for this module. The program is rather simple, but it works fine here. First, the servo library is imported, then the servo is set up on pin 3. Next, the position loops through the following angles from collinear, with a 1 second delay between each angle. 0 degrees, 15 degrees, 45 degrees, 15 degrees, 0 degrees, negative 15 degrees, negative 45 degrees, and negative 15 degrees. From there it loops back to 0 and the process repeats. It's worth noting that the program and flowchart use 45, 75, 90, 105, and 135 degrees instead. This is because the servo moves from 0 to 180 degrees and is placed so that 90 degrees is the 0 position. We will now move on to the tests. Here I will hold the body still and align the servo with the center point marked on the paper. The paper has all 5 angles we will use marked out, and will help show the accuracy of the servo. When I power on the system, we can see that the tail is able to generally align with the 5 marked points. It's important to note that choosing the cheapest servo I could find has some consequences, however, as the tail often does this wiggling motion. I suspect this is due to the servo moving to the target angle quickly, then the inertia of the tail moving it past that angle. The servo then tries to counteract this overshoot by moving back in the opposite direction but overshoots again. This effectively generates a positive feedback loop, causing the tail to wiggle. Luckily this wiggle is not too significant, and if I'm lucky it won't cause any issues in the future. If however it persists, I have a couple of options. First of all, I can try and reduce the weight of the tail, which should reduce the inertia and reduce stress on the servo. If however this is unable to reduce oscillations to a manageable point, I have a large servo that I may be able to fit to the body. This however would require either redesigning much of the body or trying to retrofit it somehow due to it being much larger than the current servo. However, for the purposes of this module, I do not consider it much of an issue. That concludes part 2, thank you for watching.